Ladies and gentlemen, in this very moment I have both the honor and the pleasure to give you the AR Max 1 Younger 1.
Public notice of nonprofit educational fair use in compliance with Title 17, Section 107 of the United States Copyright Code. Federal law allows citizens to reproduce, distribute, or exhibit portions of copyrighted motion pictures, video media, or video discs under certain circumstances without authorization of the copyright holder. This infringement of copyright is called fair use and is allowed for purposes of criticism, news reporting, teaching, and parody. Public notice of nonprofit educational fair use in compliance with Title 17, Section 107 of the United States Copyright Code. Federal law allows citizens to reproduce, distribute, or exhibit portions of copyrighted motion pictures, video media, or video discs under certain circumstances without authorization of the copyright holder. This infringement of copyright is called fair use and is allowed for purposes of criticism, news reporting, teaching, and parody. Public notice of nonprofit educational fair use in compliance with Title 17, Section 107 of the United States Copyright Code. Federal law allows citizens to reproduce, distribute, or exhibit portions of copyrighted motion pictures, video media, or video discs under certain circumstances without authorization of the copyright holder. This infringement of copyright is called fair use and is allowed for purposes of criticism, news reporting, teaching, and parody.
consider that at least whoosh. Now that didn't expect that.
Solch eine Schräglage, verehrte Gäste, bei allem Wohlwollen Da rutschen natürlich die Kaffeetassen auf die Seite und hängen dann in den Seilen. Aber das sind die Grenzmanöver. Damit wird einmal bewiesen, mit wie viel Technik, mit wie viel Akribie die Aerodynamik berechnet wurde, dass mit diesem Luftfahrzeug, Wahnsinnsgerät, derartige Fluglagen erreicht werden können. Hat natürlich auch etwas Fantastisches.
Systems are so incredibly accurate that our two pilots today, they're both experimental test pilots, Peter Chandler and Wolfgang Hansmeyer, are able to maneuver the aircraft just like this, effortlessly.
Ich kann nur noch mal wiederholen, verehrte Gäste, Sie werden nie wieder auf einem Flughafen oder
One of the most important things about this aircraft, aside from the fact that you can operate from surprisingly small airports for such an enormous airplane, one of the most important features is that it has the lowest fuel burn per seat of any long-haul wide-body jet. It burns less fuel for every passenger it carries than any other jet, and that's by around about 20% less than its next nearest competitor.
Greetings fellow air travellers. This video is for everyone who has ever bought an airline ticket. I'm going to make this video as short as possible, but the large amount of information included will inevitably dictate the length, so please bear with me. Hopefully at the end of this video I will have convinced you that there is a deception going on right in front of your eyes. This affects every person that has ever travelled on a modern day airliner. If you're not convinced, then I hope that this information will have planted a little seed of thought that you can use later on when something else related comes to light. We have been told that the fuel for a flight consists of about 50% of the ticket price. We have accepted this information for many, many years. What if that information was wrong? What if the manufacturers knew this and chose to keep it quiet? We've all experienced walking up the airplane steps, stopping in the queue and looking around, We look at the wings, we look at the engines, and marvel at the size of these amazingly powerful pieces of modern technology. Sometimes we also see the fuel being pumped into the wings. We think nothing of it. But what happens if we put our common sense hat on and take another look? The Airbus A380 is a truly amazing feat of engineering. In a purely bums-on-seats configuration, this aircraft can take almost 900 passengers. A typical coach takes about 50 passengers, so the A380 can take approximately 18 coachloads of people. That's a lot of people. According to their own specifications, the A380 can take 323,525 litres of jet fuel in the wing tanks. That works out at roughly 260 metric tons, or 130 tons of fuel in each wing. I'll let that sink in for a minute because that is very, very heavy. That is the same as 16 red London double-decker buses on each wing. Or to put it another way, a herd of 22 fully grown elephants on each wing. How does that sound to you? Pretty incredible, right? But you can look this information up in the specifications and check it for yourself. Most of us have seen a plane refueling. They connect one or two hoses underneath the wing, connect that to a pump on board a refueling truck, which then pumps the fuel from underground tanks. This takes about 45 minutes for a full load. We never see the amount being pumped because the tanks are not visible. Let's make them visible and see how that looks. It would take 16 of these 20,000 litre trucks to fill the A380. Where does all this fuel go? In the wings, you say? Okay, let's take a look at the wings, and you tell me where you think it all goes. This is the A380 wing. Pretty huge. Let's put a fuel truck next to it. And another. And another. And another. And 4 more. Just for this wing. Another 8 go into the other wing. Can you see what I'm saying? Now let's take a look at the wings on these aircraft. This is the new Dreamliner taking off in a spectacular fashion. Observe the thickness of the wings. How many fuel trucks would fit in those wings? Okay, let's take a look at the fill rate. To fully fill the A380 takes approximately 45 minutes. To fill an Olympic-sized swimming pool takes about 4 days.
I think people are going to be really excited.
That is 2.5 million litres of water. The capacity of the A380 is about 8% of the volume. 8% of 96 hours is 7.6 hours. That's a lot longer than 45 minutes. So maybe the filling equipment is much faster for a plane. Let's take a look. This is filling a swimming pool. And this is filling an aircraft. To fill the tanks of an A380 in 45 minutes, you would have to have a pump and a hose that could pump 7,189 litres of fuel per minute. Let's look at something that pumps at about half that speed. Now the plane, now the fire hose. Don't you think that filling that wing with that sort of pressure would just rip a hole right through the top? It's only made of aluminium. So far, we have no room for all of that fuel. An incredible weight of fuel and a filling procedure that makes no sense whatsoever. Time to take a look at moving around with large bodies of liquid. The size of a large car's petrol tank is about 70 litres. Don't you sometimes wish that your petrol tank was bigger so you wouldn't have to fill up so often? There are reasons why this is so. Number one, the weight would drastically reduce the performance of the car. And number two, The amount of fuel sloshing about in the tank would seriously interfere with the road holding whilst going around corners. This doesn't seem to be the case with aircraft using vast quantities of fuel. Let's take a look at what large bodies of liquid does to road holding. Not a pretty sight. Now let's look at a couple of landings of aircraft and try to imagine hundreds of tons of fuel sloshing about in the wings. I think you might be getting the gist of what I'm trying to say. It is ridiculous to think that these aircraft take off, fly, bank, maneuver and land with large amounts of liquid moving in all directions. The next video clip is from the US Air Force, showing the filling and strapping down of the large bladder tanks used for in-flight refueling of their aircraft. Bear in mind that these 3 tanks are only 9,000 US gallons. This is just under 10% of the fuel needed to fill the A380. Look at the lengths these guys go to and the amount of straps needed to stop this lot sloshing around. Also, this 9,000 gallons takes up a good portion of the aircraft's cargo bay. Where on earth would you fit 10 times this amount on an A380? Is it making sense to you yet? Let's move on to the workings of a modern fan turbine jet engine. Rather than explaining this myself, I will let this short video do the work for me. Observe that at the end they actually say that the secondary flow, which is only compressed air, is the major contributor to the engine's thrust.
Hear that, boys?
What is it?
Just another narrow-body aircraft.
Hey, my atoms are shaking. Strange. It sounds far, but I bet my last proton that beast is much closer than you think. Hold on, people. It's a LEAP-powered aircraft. A leap into the unknown.
What on earth is a leap?
Something you sure haven't seen before. Everybody get ready. We're going in.
Can someone please tell me what just happened?
Sure. The engine makes a plane move forward. Thrust is produced by air being pulled in by the fan blades. Then this air is ejected at greater speed through the exhaust, creating the required pushing force. This is a principle of Newton's law. For every action, there is an equal and opposite reaction. So how is this possible?
General Souls, come with me to the bypass.
Extreme sport freaks, with me, we'll hit the compressors, combustor, and turbines.
The LEAP is a high bypass ratio engine, which means that a large amount of air bypasses the core of the engine to be ejected directly into the exhaust stream. The fan acts like a propeller. Its curved rotating blades accelerate the airflow into the engine. Lighter composite materials provide better efficiency and resistance.
Here come the compressors. Get ready. Things are gonna heat up. Feel that? It's the low-pressure compressors squeezing us. Now, the high-pressure compressors. You're gonna feel the difference.
Ultra-efficient compressors deliver optimum air pressure and temperature conditions for combustion.
It's rising up now. Let's get toasted! Gentlemen, meet your kerosene counterparts. These guys are gonna light up your day.
Already? We usually mingle inside.
Not anymore.
I thought there'd be more of you.
Normally, yes, but in this engine, fewer of us are needed.
This little kerosene particle is right. The LEAP engine burns less fuel than former engines. In addition, the fuel nozzles mix fuel and air before they enter the combustor, creating a homogeneous mixture that minimizes the peak temperature during combustion. This technology significantly reduces emissions.
Okay, let's go.
The combustion chamber. This is the heart of the engine, where energy is created through combustion of fuel and compressed air.
Are you ready? Here comes the final blast.
What a boost! Where are we now?
Turbines. Let's transfer our energy to them. This is the last extreme stage before we join the soft team. Enjoy.
Advanced material and aerodynamics make the turbines much more efficient and durable. The pressure and speed of the hot gases provide the force needed to turn the turbines and its shaft, which in turn drives the compressor and fan.
Come on, guys, don't hang around. We alone are responsible for 90% of the thrust from this baby. Here come those adrenaline junkies. So, how was it?
Fast, hot, and fantastic.
What a trip!
Are you kidding me? It was us in the primary flow that did most of the job.
Not exactly, kid. It's teamwork. We definitely need each other. We provided the energy to drive the engine, and they provided most of the thrust to make the aircraft move forward.
Hey, boss. Sounds like we're in luck today.
You said it. It's game on again, boys. Let's go.
Now let's watch how compressed air ejected at force into ordinary air reacts. This is an experiment that anyone can do at home. You compress air inside a plastic bottle, pop open the top, and see the result: water vapor. This is what is happening when the jet engines are in cruise mode. They are running purely on compressed air, and the contrails are water vapor being ejected out from the engines. While small amounts of fuel are needed to get the jet engine up to speed, when in cruise mode, the engines use very little to no fuel whatsoever. We are being charged huge amounts for fuel that doesn't exist. It's not needed to fly these amazing machines. All that's needed is the most abundant thing that we've been given: air. I will end this video here with a clip of the A380 at an airshow doing a slow pass. It looks as though it is levitating at one point, but that is the subject of the next video, which involves our little friends, the bumblebees.
Very, very slow speed. It's an awesome sight. I don't like the word awesome, but it's true in this case. Look at that. It is almost unbelievable. This, of course, is using the flight safety fly-by-wire programs that the Airbus things have installed. Overall length 73 meters. Wingspan with a max risk assured.
Please feel free to pass this video along to whoever you might think would be interested. I'm sure that ordinary airline fare payers will have something to say about the cost of the fuel being the majority of the ticket price. Time to start asking some pertinent questions to people high up in the airline industry. Thank you.
Landing, taking off, and I am looking for a fuel truck anywhere. But that said, I also don't even know where they put the fuel on the planes. Because they all got the super thin wings. Check out those wings. Still haven't seen a fuel truck. Check out our wing. Okay, so this guy did start fueling this little tiny truck here and this little tiny hose. That's not even a normal size hose that comes from a tanker truck at a gas station. I'm gonna time how long he puts fuel in the wing. Well, holy crap, if I would have known that, I would have just kept filming. It was less than 2 minutes that he put fuel in that plane. So the fuel guy spent more time setting up, putting up a ladder, filling out paperwork, and taking down the ladder, putting back the hose and everything, than he did actually pumping fuel in the wing. Look at that little thing. I'm wondering if it's propane or something. It's weird. Alright, let's fuel update.
Flaps. This is the underneath of one of the wings. Just look at the amount of hydraulics going on here, and what we're trying to look for is fuel tanks. Can you see any? There isn't any. Now this is going on, you can often see this being done in the pre-flight checks by the pilot, but those flaps, someone was saying, yeah, but on most of these big aircraft, they actually retract inside the wing, and you're talking thousands of PSI to move these sheets of metal. this is not a child's toy. You can imagine the drag. You know, I'd have never done one myself, but if you jump out of an aeroplane, the wind and the force is phenomenal. But these things are designed to cope with that. I don't know. I don't know the technical term for it, but here we go. As it goes underneath here, and look at this. Look at the thickness as well. Yeah. It is an engineering marvel. I'll turn the sound up if you want. It's quite annoying. Look, all this is going on. All the electronics, hydraulics. There's more piping as well going from to the actual gas turbine engines. There's more of the piping inside here. I mean, look at this. Look at it. Look at the actual size of it as well here, yeah? No room at the inn for those tons and tons of liquid fuel they keep telling us about. It's only a quick video, but I think it pictures speak 1,000 words. You don't need to be an engineer to realise the amount of stuff that's required. Yeah. This is heavy gear. This is proper stuff. Anyway, I'm going to give full credit to this YouTuber here, Jagira 45, Boeing 737 flaps extension and retraction. Thank you very much for this, because to me it's absolutely fabulous. Look at that. Yeah, there are no fuel tanks. Come on, can you not help me? Wow.